I'm just going to go over kind of grinding as a whole is a very large topic to cover. Same as drilling or milling, you're talking about a complete production process. So I'm going to try and break it down a little bit to kind of what the process itself is, break down some of the components and some of the bits and pieces that affect how successfully we grind, and then talk about what we're actually looking for from good grinding. So we'll just a little bit about the company, what the system is, and then what we're looking for with good grinding. So Tyrolit as a whole is Europe's largest bonded abrasive manufacturer. You can see it's nearly 700 million euro. It's based in Austria, and that's where the vast majority of our production is. But there's also 11 production facilities over 26 different countries around the world. So the grinding system itself, as I said, grinding in general is a large process to talk about. So this is quite a broad overview of the system itself. So obviously the first thing you have with grinding is the grinding wheel, and how that affects the grinding is many different ways. So obviously you can see on the left hand side you're looking at the wheel body. So with a normal grinding wheel you press a complete wheel. Obviously with super abrasives like the picture there, you're using normally metal, carbon fiber, there's one or two pressed components you can use, and that'll affect the grinding system itself in a large different ways. So that will obviously affect the weight of the wheel, that'll affect the shaft on the machine, it'll affect your finish because of how it's moving the machine, the bearings, how much you'll get from the bearings on the machine. And obviously then you still have to look at health and safety. You know, can your guys, if you have a wheel a meter wide, can your guys pick that up? Do they need machines? Then I suppose when you're looking at how it's cutting the material, your abrasive layer is going to be one of the more important parts. So obviously that affects everything within the grinding process, your finish, how quickly you can cut, what materials. So within grinding, depending on the material you're cutting, you use a different type of grit. So depending on what that grit is, how small it is, that'll obviously affect the finished part. And then obviously trying not to be too broad, but on a grinding wheel, how you create it, the abrasive layer, whether that's a full wheel or just a super abrasive layer, is you're combining three different things. You're combining the grit, the bond, which is the glue that holds it together, and then it's a filler that's evaporated off in the kiln stage. But essentially it's the bond and grit that holds the abrasive together. So the bond itself reacts with the grit. So the stronger bond you have, the less grit you need to use. The stronger bond you have, the more filler you can use, which means you can bring coolant through the wheel, which obviously reduces burning, means you can run a bit quicker. The ideal grinding wheel is essentially a load of grit free flowing in the air, but because you have to hold it together, you then obviously have to look at what different bond systems there are. You might want a weak bond system so that the wheel breaks down, so there's not too much force going into the part, or you might want a stronger bond system that holds the whole wheel together. So all of this, as I said, it's a very broad topic. So each process and each grinding wheel you're using are going to react very differently to different processes. So this is to try and give a bit of an overview about how you'd go about that. And as I said, the pour and the filler obviously affects how much coolant you can bring through the wheel. If we look then at the complete grinding system, so this is your machine and the wheel. So we had a bit of a chat about the wheel just there. If you look then at the workpiece, so again, if you look at the material it's made out of, the dimensions of it, how it's clamped, how stiff it is, and then what kind of finishing or tolerances you need to get out of it. Those are all things that are going to affect the type of grinding you're doing, the type of wheels and abrasives you're using, and how you design the process behind it. The machine itself then, there's hundreds of different machine manufacturers, everything from small bench grinders to £1 million automated machines. And again, it'll depend on exactly what you're trying to do. So if you're making aircraft turbine blades, which is an industry we work a lot with in the UK, then you normally spend £1 million, £1.5 million on a new machine. They're a quarter the size of this room for parts that might only be this big, but you'll have a complete setup. They'll be built to a specific tolerance. They'll be built so that the non-contact time, so the movement within the machine is kept to a minimum. And they're built so that you can program them quickly and easily. But if you're finishing parts, if you have, as I said, if you're sharpening scissors or knife is the thing everyone has in their shed, if you're sitting down with a bench grinder, then you need one that costs £100. And again, within the system, it'll all affect how you're grinding and what you're trying to do. So if you have a large part, you're going to need a large machine space to grind around it. You're going to need the machine to be stiff so that it holds it. And then things like the power of the spindle. If you have a heavier wheel, you need the spindle itself to be quite powerful to be able to push through the part. And then things like if you're making medical parts, if you're making knees, then you need a very precise machine because the accuracy you're trying to get to is microns. If you're manufacturing a knee, which is one of the big industries that we have in Ireland, if you're or a hip joint, say, if you're manufacturing a hip joint ball, you're using abrasives down to a tolerance of about 2 microns. So the machine you're using has to be built, precision built, stiff, and obviously has to be able to recognize those tolerances, so the part comes out all right. And then again, some of the other things that surround it. So obviously the lubrication you have on the wheel. Again, most of the time you're grinding, you'll be using some kind of lubrication or coolant. The point of that is to take heat out of the part. So as you're grinding, there's 3 places the heat will go normally. Well, 4. You'll have heat going into the part, you'll have heat going into the wheel, heat going into the offcuts, so the bits of metal that you're actually cutting, and then you'll have heat in the coolant. So obviously the more suitable the coolant is for the part, the more suitable the design of the coolant nozzle is. So if you're doing a V-section, cutting a V-section into metal, having a straight coolant design might not be the best thing. You might want to design it so that it is designed as a V, so you can get the coolant into the system. And all that affects the result you'll get on the part. So that affects as I said, the finish on the part, the burning, the force, the power. If we look at the balancing system, so when you mount a grinding wheel, there's a balancing system in the shaft, and this keeps the wheel true. So again, if your machine doesn't have a decent balancing system, the wheel itself doesn't run true, and you have issues, you make mistakes, you make parts out of tolerance. The dressing system, so again, most precision grinding, you're using it to grind a shape into metal. As I said, if you look at knees, you use circular wheels, and you're using them over so that your point of contact is very small, but you need to still need to maintain the reference tolerance on that wheel to a very high precise point. So how you're dressing it and the precision of the way you're dressing it makes a huge difference. And obviously how you're dressing it, so the tools you're using to dress it, whether it's diamond dressing, whether you're in a tooling scenario using wheels or sticks. And then finally it's the parameters. So again, it's how you set the system up. So it's the feeds you're using, the speeds, the the positions you're cutting. Are you cutting up, down, the wheel direction? And all of this, all of this stuff is obviously connected. One thing can throw the system out of whack, but as a whole, working together, you can, make some very, very precise things, and you can grind really well. So this is just a little bit of what we would call high performance grinding. So it's a little bit of, I suppose, what we're trying to get out of the grinding system, and how we'd kind of, when we come to customers, how we'd work with them to go on certain tracks. And then there's a few case studies towards the end. So we kind of look at high performance grinding as 5 different things. So most important for any manufacturer is probably the top one. So the economy, the money. How much is the machine? How much does it cost to run it? How much is the grinding? And all of those things, that's the first thing that anyone thinks of. How much does it cost me to make this part? And then I suppose how you'd affect that is a lot of the other things, and it's, all of these things will affect the grinding somehow in different ways. So if we look at the top left, if you're looking at improving the grinding process, pushing it further, trying to get it more out of it, then you're talking about improving the tools themselves. So do you use a different type of wheel? Do you run it differently? Do you use a different machine that can maybe take the same part and flip it around and do 2 processes in one? Then it's the other thing then, I suppose, from the high performance side, is whether when you have a new part come online, do you look at different materials? So if you're looking at different materials, is that, there's titaniums coming in, is that a new nickel alloy, is that, it could depend exactly on what you're trying to make, obviously, but how are you going to machine it? If you're machining aircraft blades, titanium aircraft blades, there's, up until 2 years ago, there was nobody ground them because there wasn't the systems in place. Whereas now, after 2 or 3 years work, there is a process that's there for it. So that's obviously something, when you're looking at it, have you explored all the options, instead of milling or drilling it, is there another option? And then we kind of look at the background to grinding. So grinding as a process is very different to your single point cutting, so your milling and drilling. Again, it's relatively easy to model a drill or a mill on a cutting surface. So you're talking about 1 or 2 points of contact. When you're looking at a grinding wheel, you're talking about thousands of points of contact every second. So it's very hard to define what, and to I suppose express that in the right way, to be able to model the system properly. You can do it off info you've gathered from other processes, but to be able to model it from a technical side is very difficult. And that's why obviously we partner with a lot of these people to try and look a bit more into the background of it and the science of it. And then obviously the last thing is looking at the process itself. So that's things like you can now electrochemically dress grinding wheels, where you have an electro in a chemical bath, essentially in like a coolant bath. You're using electricity to skim off bond from super abrasive wheels. And it's stuff like that where you're not actually touching the wheel and you're just taking a little bit off. And it's stuff like that that, as I said, might not be for everybody. And in general, we don't see a huge amount of it. But it pushes it in a certain way. And it might be that that's not suitable for everyone. But that's kind of part of the high performance grinding, is finding the extra bits that you can do, pushing the grinding in weird and wonderful ways. They actually, one of the uses that we use for our grinding wheels for is cleaning sewers. So they use robots to clean pipes, sewer pipes, little small ones, and they run the robot through the sewer pipes, and it actually has a grinding wheel on the front that that pulls it forward along the pipe. And that's the thing, it's about finding the bits like that. So that's kind of what we look for high performance grinding, is trying to put all that together to try and get the best result for the customer. So we have some case studies. I've tried to make these relevant to the Irish market, which is obviously a lot of medical based. So if we're looking at hip grinding, so this would be a UK manufacturer grinding metal balls for hips. You can see by swapping out a normal aluminium oxide wheel to a super abrasive, we've managed to reduce the cycle time from 10 minutes to just under a minute, or from 8 minutes to a minute and a half. So it's stuff like that, you can push it, depending on what you're looking for. And another one, so this is polishing, so this is finishing of turbine blades for the aircraft market. So we have a new wheel, so instead of convolute wheels or unitized, which are polishing and finishing wheels, we use a pressed rubber bond wheel, which gives you, because it's pressed, it gives you the flexibility of the convolute wheel, but also means you can dress shapes into it, and it acts like a normal wheel, but it's a very soft bond, so it breaks down. But we managed to outlast the other wheel by 4 times because of this, because you could redress it, because the bond system wasn't breaking down, you didn't get pullouts. So it's about finding the next step. And this is looking at aluminium oxides for the aircraft, or aluminides for the aircraft industry. So this is us developing a tool and then working with a machine manufacturer in the UK to develop a grinding machine system with the tool. So just to finish up, as I said, it's trying to be as broad as possible. This grinding as a whole is a very broad topic, and obviously your own particular process will be very particular to you. You'll have a certain way of doing it and a certain system. But it's about looking at the whole thing, holistically, looking at the whole system itself, and then looking at the grinding, where you want to be, and what goes into saving you money. Because most customers don't care about the grinding wheel. As long as it's there and it works, no one really cares. But it's about making sure, one, that it's there, but two, using it to save money, to push the process forward, to get more capacity, Anyway, thank you very much.